What is an objective function in mechanical design optimization? Imagine trying to make a product better, faster, or cheaper. How do engineers decide which way to go? That's where an objective function comes into play. It's like a scorecard that tells us what we want to improve or minimize in a design. Think of it as a clear goal set in numbers. For example, reducing weight, lowering cost, or increasing strength. This function turns complex design goals into a simple, measurable number. It helps engineers compare different options quickly and see which one is best. In mechanical design, the objective function must be something you can put a number on. If you want to make a car part lighter but still strong, you can measure the weight in grams. If you want to make a machine more durable, you might measure stress or fatigue life. These numbers are then used by computer programs to test many different designs fast. The goal is to find the design that makes the objective function as good as possible. Designs usually have variables you can change, like size, shape, or material. The objective function guides how to change these variables. But there are often limits or constraints, like maximum stress levels or manufacturing limits. The objective function works with these constraints to find the best balance. There are two main types of optimization. Single objective optimization focuses on just one goal, like making a beam as light as possible while still holding weight. Multi-objective optimization looks at two or more goals at once, like making a bike frame both light and stiff. When multiple goals compete, the process finds a set of best options called the Pareto front. These options show the best trade-offs, so engineers can pick the one that fits their needs best. In real-world projects, the objective function helps engineers make decisions based on data. For example, in designing an airplane wing, the goal might be to reduce weight without sacrificing safety. The computer tests many wing designs, each with different shapes and materials, and scores them based on the objective function. The best design is the one that scores highest or lowest, depending on the goal. Tools like finite element analysis and numerical algorithms use the objective function to explore many options quickly. This process saves time and helps engineers find the most efficient, safe, and cost-effective designs. So, in simple terms, the objective function is the heart of design optimization. It tells us what to aim for and guides us toward the best possible solution in mechanical engineering projects.